Hello and welcome back. Mrs. Saunders here. We've already learned what equilateral and isosceles triangles are, but now we're going to use some of their properties to solve some problems. So just a review on isosceles triangles. An isosceles triangle has at least two congruent sides, and we call those two congruent sides legs. Between the legs is called the vertex angle, and at the base of each leg is called a base angle. Now we have what we call the isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are also congruent. So in this triangle, if AB is congruent to CB, then angle 2 is congruent to angle 3. Okay, let's look at the triangle and mark that. AB is congruent to BC. Then the angles across from those are also congruent. Angle 2 is congruent to angle 3. Now we can flip that, and when we flip it, we call it the converse of the isosceles triangle theorem. And it says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So if we start with angle 2 and angle 3 being congruent, then we can point across the way to their sides, AB and CB, also being congruent. So let's practice that a little bit. Name two unmarked congruent angles. Well, these are two sides that are marked, right? And if we know that two sides are congruent, we can look across at their corresponding angles and know that they're also congruent. So we know that ACB is congruent to ABC. Next is name two unmarked congruent sides. Again, we've got these two congruent angles that are marked here. See those? And so if we take those and look across at their sides, we know that those are also congruent. So AD is congruent to AC. Now, I'm going to take you through a proof of the isosceles triangle theorem just so you can see how it works. So we're given this triangle, and it's an isosceles triangle because we know that LM is congruent to LP. I'm not going to mark that yet. That's going to come in later. And we want to prove that angle M is congruent to angle P. All right, so here's where we're going to start. We're going to let N be the midpoint of MP because every segment you have has a midpoint, exactly one. All right, now because of that midpoint, we know that MN is congruent to NP. And I can mark that because the definition of a midpoint. The midpoint cuts a segment into two equal pieces. Now I'm going to draw a line from L to N, which I can do. You can take any 2 points and draw a line. And now you see I have two triangles. With those two triangles, I know that LN is congruent to LN. We've talked about that before. That's the reflexive property. And then now I'm going to pull in that given information. The given information doesn't always have to go on top. It can come in the middle. So LM is congruent to LP. That's the given information, and I'll mark that. Now, what do you have up there? You've got two triangles with three sets of congruent sides. So I've got two congruent triangles because of the side, side, side shortcut. If I have two congruent triangles, that means that all of their corresponding parts are congruent. So I know that angle M is congruent to angle P because of CPCTC. So that's the proof of the isosceles triangle theorem. Now you don't have to memorize that, but I think it's good for you to see where some of these theorems come from. A special type of isosceles triangle is an equilateral triangle. And we have some special information in regards to equilateral triangles. One is that a triangle is equilateral if and only if it's equiangular. We also know that each angle of an equilateral triangle measures 60 degrees. All right, so basically, if all the sides are the same, all the angles are the same, and all the angles are 60 degrees. So let's use that information now to see if we can solve this problem. It says find the value of each variable. Okay, this one's a little bit tricky because there's a lot going on, but what do we have here? We've got these two congruent sides which means the angles across from those sides are also congruent. So if this is 2x here, oh, this is also 2x. And now what do you see we have? All the angles are the same. See that? Look at they're all 2x. If all the angles are the same, it's an equiangular and equilateral triangle, which means all the angles are 60 degrees. So that means 2x equals 60. That means x equals 30. Now we found that this was an equilateral triangle. All the sides are the same. So that means I can take this 3 here, that side, and set it equal to 4y minus 5. Now I can solve for y. Add 5 to both sides, divide by 4, and I get y equals 2 inches. There was a lot in that one. You might need to rewind the video and watch that one again. All right, how about this one? Again, find the value of each variable. What do we have? Well, we've got congruent sides. Okay, so that means the angles across from those sides are also congruent. So this is 80 up here. This is also 80 down here. If we want to find x, we need more information about this angle here. Well, how many total degrees are there in a triangle? There's 180. So if there's 80 here and 80 here, that's 160, which leaves us 20 degrees left over for angle A. So we know that 6x plus 8 equals 20. And we can solve for x. Subtract 8 from both sides and divide by 2. And then y, since we know that those sides are congruent because they're marked, we can set those sides equal to each other. 4y minus 2 equals 2y plus 2. Add 2 to both sides, divide by 2, and we get y equals 2. And that's it. Some properties of equilateral and isosceles triangles that help us solve some problems. Thanks for being here.